okay? When we're talking about area loads and live loads and dead loads, and when they first give that to us, they're gonna be saying PSF, okay? Pounds per square foot. Uh-oh. Okay, or pounds per foot squared, okay? That's a little bit different for us. That is not an intensity, okay? When we are given pounds per foot squared, what we need to remember is almost back to hydrostatics. When we have to multiply by the width of the wall, that's exactly what we're doing here in load tracing. We will be taking the area load, the decking, and multiplying it by that tributary width, and it shrinks down that distributed load and makes it back into 2D to get us to distributed line loads. Okay, so we're going to go from area loads, and then we're going to multiply pounds per feet squared by our tributary width, which is also going to be in feet. Could be in inches, I suppose, but usually when we're doing load tracing, we only have to worry about pounds, feet, inches, everything in US units. So for distributed line loads, we should get pounds per foot. Okay, and that's where we feel most comfortable. We're right back to distributed loads. That was loud, sorry. We're right back to distributed loads. And that's then what we have to multiply the span length by. So then we get point loads, which is just going to be pounds. Okay, so this could be pounds, this could be pounds. We could have kips, which is equal to 1,000 pounds. Okay, all of those are definite examples of. Okay, so when we get to point loads, we should just be getting pounds, hashtags, kips, whatever the case may be. Okay, so now we're going from area loads to distributed loads to point loads. Hopefully that's the goal. Okay, I'm going to do one little example and then we'll do the majority of it, but it's just kind of something to think about. Let's just go ahead and excuse my drawing. My nose is going to be super good. Okay, so I'm going to say that this is all my decking. Okay, it's concrete. And then I'm going to say it's supported on either side by a girder. And then this side has a girder too. Okay. I think I know how to draw this better. Maybe. We can kind of see it, right? There's a beam underneath the concrete slab. Calling it a girder. That's what's holding it up. Each corner is going to be supported by a column. Okay, so we're going to say, what are the column reactions? Column reactions, question mark, if the live load and dead load is equal to, let's say 50 PSF. That's how it's always going to give it to us, okay? I'm going to say that the distance from column to column or end to end of the concrete slab is going to be 10 feet. This will be 5 feet. Okay, that should be all that we need. We'll have girder 1, girder 2, all of my columns, column 1, column 2, column 3 is back there and hidden, and then column 4. I'm going to put G1 over here. And then this would be my decking. Okay, so that decking is my loading here, 50 pounds per square foot. It includes my dead load, which is the how much the decking is, how much the decking weighs, and the live load, so wind, snow, all of that conglomerated into 50 pounds per square foot. Okay, so every little square foot is 50 pounds. We need to get all the way to those columns. So what we are going to do is we're going to say, okay, this decking goes to the girder 1 and girder 2, and then to column 1, column 2, column 3, column 4. So that decking, because it is 5 feet, is going to be split in half, right? Right here. That decking is going to go this way and this way. Half of it's going to go to girder 1 and half of it's going to go to girder 2. It's completely uniform, but girder 1 is in charge of half of it, girder 2 is in charge of the other half, so I get to split that distance between the two, the midway point between girder 1 and girder 2. That's going to be my tributary width. So if I just take my girder 1 side, here's all my decking. Here is my girder and then my columns. Okay, my decking is now 2.5 feet and still 50 pounds per square foot. It's now just half of it for my girder 1. Okay, so to get girder 1, I'm going to extract girder 1, and all I want is a distributed load on my girder 1. Okay, to get to a distributed load, and to get it flat again, I'm going to take all of those little arrows and just put one stretch of arrows here. But I have to do that by making the intensity of each one of these arrows much more, because I'm going to be multiplying by that distance. So I'm going to go 50 pounds per foot squared times 2.5 feet. Okay, because of units, 1 foot gets knocked out, one of the squareds get knocked out. So I get 50 times 2.5. I get 125 pounds per foot. Okay, so now I no longer have that width. So if I do, just drawing now, this is my girder 1. This is what I have here. Just one layer of arrows, nice and 2D. That is 125 pounds per foot. Okay, and that girder 1 is 10 feet wide. So then I know my next step should be 125 pounds per foot times 10 feet is 1,250 pounds. Okay, so everything that's happening on girder 1 is 1,250 pounds. And then to get to the columns, here is my column 2 and my column 4. And when I'm talking about column 1s and column 4, so those are fixed supports, but we are only going to do the vertical reaction. Everything is vertical already, so we just need to add in the Y direction for column 2 and column 4, or my CY2, C2Y, C4Y. Only Y directions, and because that is directly in the middle, because it was a uniform distributed loads, I can do 1,250 divided by the 2, so each one of my columns is getting 625 pounds. Okay, so that's kind of how we're working. What I really wanted you to see in this problem is getting from the decking, squishing it down into making it a distributed load on my girder. I'm now taking that distributed load, doing what I usually do, multiplying by the span, and then dividing that in between my 2 columns. Okay, if this was not uniform, I'd have to incorporate my moment equation, but we won't